The scorching Arizona desert hides a mechanical graveyard where the legendary titans of the sky go to die. But within the sprawling 309th Mark facility, death is merely an illusion. It is the roaring, violent beginning of a magnificent resurrection, where old warbirds face the ultimate equalizer, the Mega Shredder. Beneath the relentless sun, the heat waves shimmer over thousands of decommissioned bombers and fighters. These once unstoppable flying fortresses, which dominated the stratosphere and defied the limits of human engineering, now sit in utter silence. But this tranquility is violently shattered as the heavy diesel engines of the industrial shredder roar to life. The earth trembles under the sheer, terrifying torque of the dual-shaft beast. It is a machine designed with a single, brutal purpose: to tear through military-grade titanium and aluminum as if they were fragile paper. The massive conveyor belt groans under the weight of an entire aircraft fuselage, feeding it relentlessly into the crushing steel jaws. The devastation is absolute and deafening. Metal screams as thick structural beams are pulverized into unrecognizable, jagged fragments. The air is instantly filled with the acrid scent of vaporized hydraulic fluid and the raw, electric tang of ripped steel. Yet this is a necessary violence. Every shattered rivet and twisted panel is a vital ingredient in the alchemy of modern recycling. The shredder consumes the legacy of flight, reducing it to a chaotic cascade of raw material. Beneath the deafening roar, a complex system of magnetic separators and eddy currents begins the meticulous task of sorting the chaos. Ferrous metals are violently pulled from the stream, while lightweight aluminum is launched into separate collection bins. Through the swirling dust and the relentless mechanical pounding, the true value of this graveyard is revealed. This is the first step in a journey that will take these broken fragments from the harsh desert floor to the blinding heat of the foundry. As the sun climbs higher, casting long, stark shadows across the boneyard, the mountain of shredded metal grows. It is a testament to human engineering, both in the creation of these flying marvels and in the sheer power required to tear them apart. The relentless jaws continue their feast, oblivious to the history embedded in the metal they consume. Wings that once sliced through the clouds and engine casings that contain the fury of immense thrust are all reduced to uniform pieces. The conveyor belt carries the pulverized remains away, sparks flying in brilliant showers as hardened alloys resist the bite. The heavy metals stand ready to leave the boneyard, proving that the legacy of aviation never truly dies. It is simply broken down, preparing for an extraordinary rebirth. The initial chaos of the shredder gives way to cold, calculated force. Here, the densest, most resilient aerospace alloys face the unstoppable pressure of an industrial guillotine. The raw destruction transforms into surgical precision as the elite metals are isolated and conquered. Moving deeper into the heart of the recycling complex, the nature of the operation shifts from chaotic tearing to overwhelming pressure. The shredded fragments, a tangled mix of ordinary aluminum and highly specialized alloys, are fed into the next critical phase. This is where the true treasures of the boneyard, the ultra-dense, heat-resistant metals used in jet engines and landing gear, are isolated. A massive hydraulic shear, an industrial guillotine of terrifying proportions, stands ready. Its hardened steel blade, driven by immense fluid pressure, cleanly severs materials that would destroy lesser machines. As the operator engages the controls, a deep, resonant groan echoes through the facility. The hydraulic rams descend with unstoppable force, making contact with a thick strut of aerospace-grade titanium. With a deafening, explosive crack, the strut is instantly severed. Following this brutal precision, the material enters the density separation matrix. This is where the physical properties of the metals dictate their destiny. A heavy-duty, high-frequency vibratory table shakes the fragmented pieces with aggressive, rhythmic intensity. The sheer kinetic energy forces the materials to separate based on their specific gravity. The lighter aluminum alloys float to the top of the vibrating mass, while the dense, incredibly valuable pieces of Inconel, steel, and tungsten sink to the bottom. It is a mesmerizing dance of physics and engineering. High-velocity air jets are strategically positioned along the separation line, blasting the lighter debris away and leaving only the heavy, premium fragments behind. These heavy metals, now completely isolated, drop heavily into reinforced steel collection bins. The sound of these dense alloys hitting the bottom is distinct, a deep, resonant clanging that signifies purity and immense value. The operation runs with relentless efficiency. Every stage is monitored, every drop of hydraulic fluid is pressurized to its absolute limit, and every pound of scrap is accounted for. The extreme forces applied to these materials serve to strip away the useless and the obsolete, revealing the pure, indestructible core of the aerospace alloys. Millions of dollars of advanced materials, once destined to rust in the desert, are now primed for the foundry. The relentless mechanical sorting is a testament to the ingenuity of modern recycling, transforming a chaotic graveyard into a highly organized, invaluable resource stream. the cycle continues. The physical sorting gives way to a crucible of extreme friction. The toughest alloys are subjected to brutal abrasive forces that generate blinding heat, stripping away the final layers of impurity. They must scrub themselves clean through unrestrained violence before the artificial intelligence takes control. The journey of the recovered aerospace metals now enters a phase of intense thermal and abrasive stress. The heavy fragments of Inconel, steel, and tungsten, having survived the shredder and the guillotine, are subjected to the thermal gauntlet. This stage utilizes extreme friction to strip away any remaining sealants, paints, or bonded composites that survived the initial dismantling. The massive fragments are fed into high-speed, heavy-duty rotary trommels. Inside these massive spinning drums, the pieces of metal violently crash into one another, acting as their own grinding media. The deafening, continuous roar of thousands of pounds of dense metal colliding is accompanied by brilliant flashes of sparks as hardened edges strike against one another. The kinetic energy generated inside the trommel is immense. The friction rapidly elevates the temperature inside the drum, causing the remaining impurities to smoke and carbonize under the intense heat and pressure. It is a brutal, self-contained inferno of abrasion. The heavy steel walls radiate the heat, while powerful extraction fans suck the dark, acrid smoke away, revealing the increasingly polished and purified surfaces of the underlying superalloys. As the material exits the trommel, it is significantly altered. The jagged, painted fragments are now smoothed, metallic, and incredibly hot to the touch. The abrasive process has revealed the true, naked surface of the metals, making them perfectly prepped for the highly sensitive optical sorting that follows. But before they reach the AI, they must pass through the final magnetic sweep. Massive electromagnets, humming with terrifying power, are suspended over the fast-moving conveyor belts. The hot, glowing fragments pass beneath the magnetic fields. With sudden, violent snaps, the ferrous steel pieces are ripped from the belt, flying upward against gravity to slam into the magnetic plates. The non-magnetic Inconel and the ultra-dense tungsten continue their journey, completely unbothered by the invisible forces above them. This magnetic separation is absolute and ruthless, ensuring that the streams of metal are fundamentally divided by their elemental properties. The environment is harsh and unforgiving, the air thick with the smell of vaporized coatings. The brute force has done its job. The fragments, now clean, hot, and separated by magnetism, are finally ready to be judged by the ultimate, unblinking eye of the machine. The stage is perfectly set for the next evolution. The era of brute force ends and the reign of the machine mind begins. The heavily processed metals plunge into the pristine darkness of the isolation chamber, where advanced lasers and artificial intelligence will judge their ultimate worth. The chaos of the boneyard transforms into pure, calculated precision. The transition from the chaotic, dusty environment of the mechanical shredders to the sterile, highly controlled domain of the artificial intelligence sorting facility is dramatic and absolute. The heavy conveyor belts, carrying the hot, purified fragments of Inconel and tungsten, enter a massive, soundproofed isolation tunnel. As the heavy industrial doors seal shut behind the material, the deafening roar of the outside world is instantly extinguished, replaced by the low, continuous hum of advanced computing systems and climate control. The darkness of the tunnel is pierced only by the sharp, intense beams of laser sensors and ultraviolet inspection lights. The metals are moving into the brain of the recycling operation. As the fragments travel deeper into the dark facility, they are subjected to an uncompromising barrage of optical and chemical analysis. The first line of defense is the high-speed three-dimensional laser mapping matrix. Dozens of intersecting green laser beams sweep across the moving conveyor, instantly calculating the volume, shape, and exact dimensions of every single piece of metal. This data is fed into the central mainframe, which processes millions of calculations per second. Immediately following the mapping, the metals pass under the X-ray fluorescence scanners. This is where the true magic of modern recycling happens. Needle-thin beams of X-ray energy bombard the metal fragments, causing them to emit a unique fluorescent signature based on their exact atomic composition. The sensors capture these light spectrums in milliseconds, allowing the AI to identify the exact chemical makeup of every piece. The sorting action itself is a breathtaking display of robotic precision. Based on the instantaneous decisions made by the AI, high-speed pneumatic ejectors and Delta Spider robots spring into action. Targeted blasts of compressed air hit specific fragments with the force of a cannon, launching them perfectly into separate chutes. For the incredibly heavy blocks of tungsten, lightning-fast robotic arms descend, their vacuum suction cups grabbing and relocating them in fractions of a second. The AI system simultaneously packages them into highly secure, atmosphere-modified containers. The pure Inconel blades are sealed in heavy polymer trays infused with argon gas. The completely sorted, incredibly valuable aerospace metals roll out of the facility, ready for transport. The journey of rebirth is meticulously finalized, and the pure technological gold is loaded for the foundry. The desert journey ends at the gates of the aerospace foundry, a temple of extreme heat where the laws of thermodynamics are pushed to their limits. Here, the salvaged metals will face a 3,000-degree inferno, melting down their past forms to forge a flawless, single-crystal future for the next generation of flight. The heavy haul truck arrives under the cover of darkness at the aerospace foundry, an imposing industrial fortress. The sealed crates of tungsten and Inconel are unloaded with massive overhead bridge cranes, the sheer weight of the recovered materials groaning against the steel chains. Inside the pristine receiving bays, the argon-sealed polymer trays are sliced open by automated robotic scalpels. The flawless, silver fragments of the recovered alloys are exposed to the air once more, gleaming under the harsh white LED lights. They are prepped and ready for the ultimate transformation, the vacuum induction melting furnace. The environment inside the melt deck is terrifying and awe-inspiring. A colossal, two-story furnace dominates the space. As its massive steel lid grinds open, a blinding 3,000-degree white-hot glare violently illuminates the room, radiating a heat so intense it distorts the air into chaotic waves. The pure pieces of salvaged Inconel are fed into the roaring, superheated abyss. The moment the solid metal hits the liquid pool, massive sparks and solar flares of plasma explode outward. The old aircraft parts are swallowed by the blinding white soup, instantly losing their shape and becoming a turbulent, glowing liquid. To achieve the extreme temperature resistance required for modern engines, the impossibly dense blocks of shattered tungsten are dropped into the churning liquid. Because tungsten possesses the highest melting point of any metal, it does not liquefy immediately. Instead, the heavy blocks sink into the glowing orange matrix, slowly dissolving as they perfectly alloy with the aviation gold. With the alloy perfected, the liquid metal is poured in the darkness of a vacuum chamber. A brilliant, glowing stream flows flawlessly into a highly complex ceramic mold of a modern turbine blade. The metal freezes from the bottom up, forming a flawless, single continuous crystal of superalloy. When the ceramic shell is finally blasted away, the reborn masterpiece is revealed. A high-speed CNC mill drops down, cutting the final mounting route with surgical precision. The finished turbine blade shines with an impossible, mirror-like silver perfection. The chaotic, dirty scrap harvested from the aircraft boneyard has been completely cleansed and reborn into the bleeding edge of aviation technology. The metallurgical resurrection is absolute and complete, waiting to conquer the skies once more. The reborn metal is flawlessly integrated into the heart of a next-generation turbofan engine. It awakens with a deafening roar, defying gravity once more to draw a brilliant white contrail across the roof of the world. The Zero Waste Initiative has triumphed, turning the graveyard of giants into tomorrow's beacon. The surgical precision of the final assembly plant stands in stark contrast to the brutal destruction where this journey began. The reborn silver turbine blade is delicately held by a robotic gripper and slid flawlessly into the incredibly tight titanium dovetail slot of a massive jet engine fan disc. An electron beam welder fires in a vacuum chamber, its blinding green-white beam fusing the blade to the disc at the molecular level. The blade is now a permanent part of the engine core, a crucial organ in a massive mechanical beast. The fully assembled engine is hoisted by enormous gantry cranes and perfectly bolted onto the carbon fiber wing of a gleaming, factory-fresh commercial airliner. The colossal hangar doors open, revealing the bright morning sun. A massive tow tractor slowly pulls the gigantic aircraft out onto the tarmac. The umbilical cords of the ground power units are severed, and the aircraft becomes a self-sustaining entity of thrust and metal. Inside the dark cockpit, the pilot engages the ignition. Deep within the belly of the engine, the Inconel blade, born from the scrap of the desert, begins to spin. Jet fuel atomizes and meets the igniter sparks, detonating into a continuous, perfectly contained inferno. The blade holds its shape perfectly, spinning at thousands of revolutions per minute inside a hurricane of fire, unfazed by the apocalyptic heat. The aircraft lines up on the runway centerline. With a terrifying, world-ending roar of maximum thrust, the brakes are released and the machine surges forward. At the point of rotation, the nose pitches up, and the massive main landing gear stretches out, leaving the Earth behind. The aircraft climbs aggressively, violently punching through a thick layer of stormy clouds, dominating the chaotic forces of nature with sheer, unrelenting power. Breaking through the dark storm, the airliner enters the pure, blindingly bright, freezing stillness of the stratosphere. The massive engines blast exhaust into the sub-zero air, instantly creating thick, beautiful, crystalline white contrails. The reborn metal is now drawing a brilliant white line across the deep blue sky, leaving a temporary, beautiful scar of progress across the heavens. As the airliner flies into a breathtaking, fiery sunset, the cycle is undeniably complete. The chaotic scrap of the boneyard has been entirely cleansed and reborn, soaring into the endless dark.